This is section 11.5. We're going to be talking about recursive rules for sequences, just a different way of writing a formula for the sequence. And your homework, 56 through 70. A little bit of vocabulary to get us started. A rule for a sequence that gives a sub n as a function of the term's position, number, n, in the sequence is called an explicit rule. So let's say, for example, I say a sub n is equal to n plus 2. This is an example of an explicit rule. If I know what n is, I plug it in and I get the term. A rule for a sequence that gives the beginning term or terms of the sequence and then an equation that tells how a sub n is related to one or more preceding terms is called a recursive rule. So an example, so let's suppose a sub n is equal to the previous term, we call it a sub n minus 1, plus 5. So whatever the prior term was, we're going to add 5 to it. Okay? So this would be an example of a recursive rule for a sequence. An example of an explicit rule would be a sub n is equal to 4 minus 9n. We know that n stands for the term number. So if I wanted to find the 251st term, I would plug in 251 right there, and I would do the math, and there you go. I could find the 251st term. On the other hand, an example of recursive rule, so here we have a sub n is equal to 4 minus 9 times the prior term. When I say n minus 1, that means the term right before the one I'm looking for. If I'm looking for the third term, I would need to know what the second term is. If I want the 251st term, then I would need the 250th term. But if I want the 250th term, I need the 249th term, which means I need to know the 248th, the 247th, the 246th. You get the idea. Write the first 6 terms of the sequence. So, a sub 0 is 1, and a sub n is n times the prior term. So, I told you the first term, a sub 0, is 1. To get to the next term, I multiply the term number times the prior term being 1. The term number times the prior term, I get 1 again. Let's look at the second, well, a sub 2. To get a sub 2, I take n, which is 2, and multiply that by the term that I just found. 2 times 1 is 2. A sub 3. I need to take 3 and multiply it by the term that I just got. 3 times 2 is 6. A sub 4. I take my 4 and multiply it by the 6. I take my 4 and multiply by the 6, and I get 24. To get a sub 5, I take 5 and multiply it by the number I just found, and I get 120, and we could keep on going. But I only wanted these terms. All right, find the first 4 terms of the sequence where a sub 1 is equal to 2, and a sub n is equal to a sub n minus 1, which means the prior term. Subtract 3. So, first term is easy. I gave you the first term. A sub 1 is equal to 2. Now, to get the next term, I have to look at the prior term. That's what that means. Look at the prior term and subtract 3. Now the prior term was 2. I want to subtract 3, and I've got -1. To get the next term, I have to look at the prior term, which is -1, and subtract 3. -1 subtract 3 gives me -4. To find a sub 4, I've got to look at the prior term, which is -4. And the formula says subtract 3. I get -7. So my first terms, we have 2, -1, -4, and -7 would be my answer. Let's do another example with a little bit more complicated formula. So a sub 1 is 5. I already gave you that. A sub 1 was 5. Now a sub n says 3 times the prior term and then subtract 4. So I need 3 times the prior term, subtract 4. 3 times 5 is 15, subtract 4, and I get 11. Now, to get the next term, I need 3 times the prior term, subtract 4. 3 times 11 is 33, subtract 4 is 29. To get the next term, I need 3 times the prior term, subtract 4. And I'm not sure what 3 times 29 is, so let's look at it. 3 times 29, we've got 27, and we've got 87, so we're going to have 87, subtract 4, and we get 83. So the sequence 5, 11, 29, 83. All right, have you worked that one? Have you worked that one on your own? So those two I'm going to have you do on your own. First 6 terms. First term is 1. Second term is 1. The next term, add the 2 prior terms. So first term is 1. Second term is 1. The next term, add the 2 prior terms. The 2 prior terms, I had 1 and 1. I add those together and I get 2. To get the next term, I add the 2 prior terms, which is this one and this one, and I get 3. To get the next one, I add the 2 prior terms. 2 plus 3 is 5. To get the next one, I add the 2 prior terms. 3 plus 5 is 8. This is a very famous sequence called the Fibonacci sequence. All right, let's do another sequence that's kind of similar to the Fibonacci sequence, just starts with different numbers. So the first one is 2, next one is 3. Now to get the next one, we add the 2 prior terms. So 2 plus 3, that 2 and that 3, add them together and I get 5. To get the next term, I add the 2 prior terms, which is these 2. 3 plus 5 is 8. 5 plus 8 is 13. And 13 plus 8 is 21. All right, example 6, same idea, only this time I'm subtracting the 2 prior terms. I will leave you to do this one on your own. I believe you can do it. Just remember that subtract, not add the 2 prior terms. Okay, write the explicit and recursive rules for the arithmetic sequence. Well, explicit rule, we remember how to do that. That was that a sub n is equal to the first term plus d, the common difference, times n minus 1. For some reason, the person that made these notes switched the order of these two, but it's the same thing. Now, the recursive rule, I have a sub 1 is equal to 15, and a sub n is equal to the prior term plus 5. Okay, so here we have an example of writing explicit and recursive rules for the arithmetic sequence, where a sub 1 is 15 and the common difference is 5. Okay, so now it's our turn. As long as we know, I think it's easier to do the explicit rule first, so let's look at that one. We need to know the first term. For both of them, we need to know the first term, and we need to know the common difference. So the first term is 7, and then we're also going to need the common difference. Common difference, what are we adding each time? So it's looking like we add 9. So if I have 7 plus 16, or 7 plus 9, does that equal 16? Yes. 16 plus 9 equals 25. So my common difference is 9. So my explicit rule is the first term plus the common difference, which in this case is 9, times n minus 1. Now, recursive rule, I prefer to start with the explicit, but the recursive rule is actually even easier, because what the recursive rule says is to get this term, I look at the prior term and do something to it. Well, what did I do to the 7? What did I do to the 7 to get 16? Well, I added 9. What did I do to the 7 to get 16? I added 9. Another example. Again, I prefer to start with the explicit rule, but it doesn't matter. We do need the first term, which is negative 10, and we need the common difference. Okay, what are we adding each time? Well, turns out we're adding 9 again, coincidentally. So the explicit rule is the first term, which is negative 10, plus the common difference, which is 9, times n minus 1. Okay, that's the explicit rule. And as I said, the recursive rule is even easier. What do I do to the prior term? So that's my a sub n minus 1 to get the next term. Well, I'm adding 9. Another example with geometric sequences. Okay, so we need the first term. First term is negative 1. We need the common ratio. What are we multiplying by? We are multiplying by 4 raised to the n minus 1. Okay, so my first term is negative 1. Now, to get my recursive rule, what am I doing to the prior term? What am I doing to a sub n minus 1 to get the next term? Well, I'm multiplying by 4. All right. Explicit rule. We need the first term, which is 9. We need the common ratio. What are we multiplying by? We're multiplying by -2. Okay. And the recursive rule, what are we doing to the prior term? We are multiplying by -2. All right. And I'm not going to do the writing time. And this is an example of a question that was on the semester exam. So I'm going to stop here.